Okay, good morning, everyone. Let's go ahead and get started. I want to welcome everyone to the Insight webinar today. We'll be talking about uptime and troubleshooting. So a lot of good information for you admins out there that are currently just administrating and managing the Stratum application, both on the back end and certainly in the world of connector and viewer. So basically we want to talk about the processes that involve your nightly process of extracting data from source files or source systems into your master files and transaction files within your Stratum database environment. And also review the processes of populating data from a Stratum database into a analysis services cube, essentially. So, and that's what they mean by OLAP database there for these, and that will relate to the Stratum viewer application. And then finally, we'll talk about some log files, and we'll provide some tips for how you can be more successful with your nightly processing. But as you may or know today, and you probably should have a pretty good idea of how your data loads into Stratum today, but essentially this is a good high-level slide of how data gets loaded into Stratum. Essentially, you've got process 1 and 2 that load in your master file data and your transactional data into your Stratum database. So typically, these are extraction programs either on the I-series that run to extract data from your ERP and then load perhaps your hosting in Stratum on the I-series. Or they could be packages, DTS or SSIS packages that will extract the data and basically do kind of the same thing, and then extract that data and get it into a SQL Server database. Either way, it's kind of the same concept where you're loading in master file and transactional data on a nightly basis, and certainly you want to make sure that those jobs are running properly. From there, once the Stratum database gets updated, then certainly if you're using viewer, there's an additional process that occurs, and that would be for the connector then to run, and then obviously to load the OLAP database for viewer and all the users that are using the viewer interface. So, and obviously those databases should sync up. So whether you're using Planner or Viewer, the users really should be seeing the same, the same numbers. The data should match up. The master file data load, typically what we see out there, except for some of the very older customers that are still running Data Tracker, but we see, obviously you're using a file there to load your master file tables, and the MF import file is really the file that you're loading, essentially, that from your source systems. So whether you're loading that from directly from the I-series or maybe from a Windows or even a Unix box for that matter, the MF import file is really what drives all the master file, all the pickup fields that come in. It also drives the previous level relationships that you may be using in your environment as well. So the MF import file is really the holding area, the pending file, the primary pending file of your master file data. On the I-series, there's a command that you would run that would take the data and then take it from the MF import file and then load it into your STCS MF10, 11, and 35 tables, because that's the permanent living place for where the actual master file data will reside. And you probably already know that. These tables should not be strange to you. You should already know that that's where your master file data resides. The MF10 table doesn't have any pickup fields, so that's strictly for your dimensions that just have short, medium, and long descriptions. And then the MF11 has up to 15 pickup fields, and then the MF35 has up to 35 pickup fields. Okay. So the xmast is the command that you could use that basically takes that data from the MF import table into your MF10, 11, and 35 tables. there's also another command, DA mass load, that you can run as well. So either way, you can get this data into your MF10, MF11, and 35 tables. These are the programs that get run, essentially, that get kicked off when you use these commands. As you can see, the XMAST actually takes advantage of some predefined RPG programs that essentially then load the data into the MF10 tables. So that's kind of the old school way of getting it done. GA mass load is the more updated program, and as you can see, it doesn't really involve those programs at all. So essentially, you could use DA mass load. I think that's what we're recommending now for running the MF import process into your MF10, 11, and 35 tables. So that's on the iSeries side. Here's on the Windows side, where, as you can see, you'll feed the MF import file from using an SSIS package, typically, if you're running current software. And then there's kind of the same concept, where you have a couple of programs there that would take the data from the MF import file and feed that into the MF10, 11, and 35 tables. So the tables are the same. The Stratum tables, whether you're running that on the iSeries or hosting it on SQL Server, the tables are essentially the same. The programs pretty much are the same as well in terms of getting data and running it from the MF import file into your master file, MF10, 11, and 35 tables. So basically, in terms of GA, I think most of the current customers that I work with are using the GI mass load command, and I know that I've set up several packages that are doing that. So that's the master file data. Let's talk about how transactional data gets loaded into Stratum. Well, it's kind of the similar concept where you've got an import file, except this time it's built for your categories. So as you can see, XX import, meaning a variable for whatever category you might be loading. For instance, actual sales would typically be AS for actual sales, and therefore your import file would be AS import. And you would feed that file, however you would want to, essentially. But normally, if you're on the iSeries, you're doing it through a series of RPG programs, and if you're on Windows, you're typically using SSIS to accomplish that. And here we kind of the similar concept again is in terms of how do we get it from the XX import table into the basically our header and detail tables down the bottom, because that's essentially where the data will reside, in the DSLs in the header and detail tables. And as you can see, there's the imp data command, which basically retrieves data from the XX import file, and it puts it into a pending file, the xpend XX table. And that's all set up by the package. So the actual SSIS package actually already has this baked into it. So essentially, it runs these commands as in sequence as needed. DA load is our server program that essentially takes it from that xpend table and then obviously loads it into the header and detail tables. So those two programs are typically kicked off in succession so that data essentially moves from the XX import file into your header and detail tables. On the iSeries side, as you can see, you've got DA load. And what DA load does is it kind of does the same thing. It takes the data from that XX import table and loads it into the, actually I skipped a slide there. Yeah, so DA load on the iSeries side loads the data from similar to the Windows side, and loads it into the header and detail tables. So you still have the imp data command and then DA load, which is named differently, but essentially it's the GI sales driver on the Windows side. And that's what takes it from the xpend table into the header and detail table. So these are the steps, the common steps that get run. DA load obviously then kicks off a series of other programs that essentially load the data into the header and detail tables and builds any necessary higher level DSLs as needed. Some of you may be running DSLs, others may not, depending on whether you're using viewer or not. If your viewer users, DSLs don't really provide much benefit. However, if you're a planner shop and you're running a lot of planner users, then obviously DSLs provide a huge benefit to you. Here on the Windows side, we can see, again, that's getting loaded in using our packages to load in the XX import file, and then GI sales driver then takes it from there and moves it into the header and detail tables. The temporary text file we did away with. We don't do that any longer, so that's been taken care of. And that way we're not duplicating data and creating additional processes that are not really needed. So again, either on Windows or Unix, it's kind of the same process here where you're kicking off the package to load in the XX import table. GI sales driver then kicks off, determines the estimated number of input records, estimates maximum memory usage, and then creates the necessary control records in the DT16 and GI10 tables. And then it kicks off DSL AG, which essentially builds the data into the DSLs, and then runs a bulk copy in memory from there into the tables, which is that's how we get away with some fast loads. We can leverage the memory on the server to use the NCNT process, which is basically a bulk copy. Populating, so basically we've got, so that's kind of populating data into Stratum. And so we've got, how do we get it from there into the viewer product so that we make sure that the data is the same? So if you're hosting Stratum here on the iSeries or on Windows, basically if you're using viewer, then you're definitely running a Windows box with SQL Server. And certainly we want to make sure the data is the same, obviously, so you have consistency between the Stratum database and the viewer cube. When you're on the iSeries or Windows, first a couple of programs need to come into play here before we run the connector, and that's the load OLAP program. And on the iSeries, it's called DA load OLAP. And on Windows, it's called GI load OLAP. But essentially what these things do is these programs prepare the master file data for the connector processing. So what they do is they query the header and detail tables for the years that you specify, or for all years. And it goes out and finds all the necessary distinct keys for all your dimensions. And you can specify in these programs what dimensions you want to include, or if you just want to run all of them. And what that does is it creates a master XX table for each one of your dimensions with all those distinct keys in them. So for dimension 1, you'll probably have master 01, and if it's a company level, you'll probably only have maybe a couple keys in there or maybe one if you only have one company. However, at master 33, which is item level for Stratum customers, you're going to have a lot of unique keys in there. So that'll be a lot bigger table. So when load OLAP runs, at the end of the program, then you'll have a series of master XX tables for all the dimensions that you're processing, that you anticipate to process in the connector. The second program then needs to run, and that's create OMAST. And on the iSeries, it's called DA create OMAST. And on the Windows side, it's called GI create OMAST. And it does this exact, kind of the same thing. It goes out, and what it does is it looks at those master tables, and it marries it up with the additional pickup fields in the MF11 and 35 tables and the descriptions in these tables, MF10, 11, and 35. And it marries them up with those keys. So at the end of this process, you'll have a series of mass tables, essentially the same number of tables, mass 1 through 99 if you're running up to 99 dimensions. And those will have all the distinct keys along with their pickup fields and well, basically along with their pickup fields, essentially. So that's what these programs do, and so it's imperative to run these both on the server side before the connector processes. Which brings us to the connector. So obviously the connector then would be kicked off, and then what the connector does is it takes that data, both the data from your data tables and from those mass tables, and then creates your your viewer cube in analysis services. And so that gets kicked off on a nightly basis after your Stratum data loads. So here we go on the iSeries side, kind of an overview of what we just talked about. We've got the master file loads for getting the data loaded from MF import into the master file data. We've got imp data, which takes the data from the XX import table and loads it into Stratum. And then we want to kick off load OLAP and create OMAST. And that kind of finishes off the series of programs that get run on the Stratum database. And then what iSeries does, then once that finishes, typically for my iSeries customers, I'll have them kick off a remote command, which kicks off this connector executable with a batch argument. And that then essentially processes the cube. So this is a pretty good slide in terms of a high-level view of what processors run where and what sequence. And then on the Windows side, similarly, you've got the packages that are feeding from the MF import table, loading the MF import table, and then running GI mass load to get it from the MF import table into the 10, 11, and 35 master file tables. The next step is to load our XX import tables data for all of our categories. So you might have a series of loads here for AS import, open orders import, OO, BD for budget, all your categories that you're loading here would be within this step. Okay, so that loads in your data, your transactional data, and then your load OLAP and create OMAST run on Windows as well. So nothing really drastically different here in terms of whether you're hosting Stratum on Windows or the iSeries. And then from Windows, then you would probably you'd have a package that would run this entire process. And you might have some sub-packages in there that kick off some of the sub-processes, but certainly, overall you'll have a master package that will kick off the entire process. And then the connector runs, obviously, to kick off your viewer cube build. So yeah, those are pretty good slides there. So let's talk about, so now that we understand how data gets loaded into Stratum and all the steps that are involved, well, how do we make sure that, some of the stuff runs properly? Well, what you want to do is, you definitely want to assess your log files. And so on the iSeries side, you'll have a series of files that you can go into and you can even, on some commands, you can even call, you can even tell it where to put some of the log files. But by default, as you can see, you get some default log files on the iSeries called QDS-SC and the QDS-SC segment number. And typically, depending on what usual profile kicks off the DA load, will dictate where those log files will exist. Typically, they're in their spooled file directory. On Windows, or Unix for that matter, the GI sales driver command actually has a log file parm that you'll specify a directory in which those log files get created. If you don't use that, then what happens is all the log file information just gets dumped into GI log, and it'll have all that information in it. GI log is a default log file that gets created in the DT data folder for your Windows Server directory. Normally when we implement, we do specify a log file directory and we put it into its own directory called DT logs. When you look at the log file for your Stratum loads, the GI sales driver, as you can see, is a program that runs, in this case we're talking about DA load, and what this does is that either way, to be honest with you, on the iSeries or for that matter on the Windows box, you're going to see the log file should look identical. So now, as you can see, GI sales driver begins its process, and it's starting to try to estimate what's going, how many records it has to move in, and now it's trying to set up the control records so that data gets properly inserted into the Stratum database and it avoids any problems in terms of prior jobs that may have failed. Once the GI sales driver does that, what happens then is it kicks off the DSL ag program, and that's basically what builds your. It takes that data and then starts building the data into the DSLs. And what will happen is it creates these DSLs in memory, and so a lot of that would happen, in memory. So we can do that very quickly. So typically, that's why we always recommend a lot of memory on either on your iSeries or on your Windows server. Here's the log file on the Windows side. As you can see, it's really nothing drastically different there. And then it does the same thing where it kicks off the DSL ag. But then we run, on the Windows side, there is something a little different called the NCNT step. And that actually takes that data from memory and then puts it into the data tables. So on the iSeries side, it doesn't have that step. So the DSL ag obviously puts it directly into the header and detail tables, whereas on the Windows side, DSL ag puts that data into a temporary file. And what that does actually is we actually put that directly into the pending table, the xpend. And then from there, it'll use the NCNT bulk copy to get it into the header and detail tables. So, what do we see normally, in errors on the server side in terms of server processing? Well, sometimes you'll see that it processes normally, but it's not using any of the records. So you'll see something like that. Typically, this will happen if you don't create your year, on a year-end maintenance. If your tables are not created and you have no import calendars created, you'll see these types of errors will happen, where the data looks good and there's nothing wrong with the data per se, but you just don't have any tables the program doesn't know where to put the data. So this will happen typically when you forget to create your future years, your future tables, and any of the calendars that go along with that. So, from time to time, we'll see that happen. This will happen from time to time as well. Some users will say, I got this unprocessed import exists, use RR to restart. And normally what this means is that a previous load didn't complete properly. And so there's a couple of tables in the mix here that kind of keep everything in sync in terms of data processing. And if you have a job that abends and it never finishes properly, your next job is not going to run unless you clean up those tables. So you can do that by using the RR trigger, or you can physically go into those tables and clean those records up. The DT16 table contains a field called complete, and you'll see that if it's equal to 1, the load is in progress, and if it's equal to 2, the load has completed. So you might have some job IDs out there with that field equal to 1, even though those jobs aren't running, and that's the problem. The GI10 table contains a field called status, and if it's equal to 10 through 90, the DSL update's not complete, and if it's equal to 99, the DSL update is complete. So again, if your prior jobs have finished not properly, the status field could potentially have a 10 in it, or something from 10 through 90 in it, which again would cause that prior error to happen. So these tables would need to be cleaned up accordingly, and you can use a simple SQL statement to clean some of that up. There's a little note down there. Obviously, you don't want to update the tables until you review the logs, until you're sure that that's indeed what happened. Okay, so a little bit of research can go a long way, just to make sure that that you do the necessary due diligence to make sure that that indeed is the problem. Another thing I want to add there is that if you're running a refresh every night, some of the customers have that luxury, if you will, to just refresh their Stratum database every night. You could, as far as the DT16 and the GI10 table, you can just wipe out those tables. Obviously you're not worried about any of that changing or anything like that. So you could just get rid of all the records. You can do a truncate table on those two tables and then run your job. You should be clear. Let's talk about what kind of log files do you get for Stratum Viewer. Well, DA load up and DA the DA create OMAS. Well, Those will run, again, on the I-series, so those should be in your log files, should be within your spool file area. And again, it depends on what user runs those commands and where those would reside. On the Windows side, again, you still have that log file switch. So if you want to tell it where to put those log files, you can, where you're running those commands, you could apply that switch, and it will put those log files as you deem necessary. And again, if it's not specified, then the log file information for these commands will end up in the GI log file. The connector has its own log file that it produces, and it's got a process log and a system log, and both of these logs are located in the folder for connector in Windows. Now this has changed, so on for the 5.1 connector, that is still true. However, for 6.0, you will have just one log file, and then you'll have a key error log file. And we'll actually hop on a server and we'll take a look at some of these directories. But the connector, bottom line is the connector has its own log file and its own directory. Also, the connector emails the log file to whoever you specify. So that's a nice luxury as well. So here we go. If we look at the log files produced by load OLAP and create OMAST, or no, just strictly load OLAP, we can see that load OLAP, this is what the log file looks like. As you can see, it gets kicked off, and then it starts looking at the header tables to get all the keys for dimension 1, 2, 3, 4, on down the line. Create OMAST then gets kicked off, and as you can see, it then takes the information and takes it from that those master tables and starts building the mass tables. There's some truncating that occurs. If you want to include a truncate argument, you can have these refreshed every night as well. The connector file, the connector executable then gets kicked off. Here we see that in version 5.1, here are the log files that get created. Your process log will kind of tell you whether you're successful or not, and then you have some additional system log file information available as well for research if needed. In version 6 or greater, you have just one log file. Like I said, you do get a key error log file, but essentially this one log file will tell you everything, whether you have a key error or anything else for that matter. Common errors that we see in the connector side. Probably the most common error we do see is a member not found in fact table, or what I call a key error. What happens here is that this error will occur if the connector process kicks off and it finds a value in the data, but it's not in the MasterXX or the MasterXX table. So you might have data within your Stratum database that never made it into the MasterXX or the MasterXX table. A couple reasons why that might happen. Your first reason is that these programs were never run. So the load OLAP and create OMAST were somehow bypassed, or they never got processed. So the necessary, for instance, if you loaded in any new customer IDs or product IDs that you ran overnight, they never made it into these master tables and the mass tables. So therefore, the connector will see that the transaction data is there, but there's no additional additional data in the mass table. The other reason is that you might have invalid characters in your data, in your master file data, and you'll need to clean those up. Normally, that will happen if you allow your users to copy and paste, or if you have transaction data or master file data that gets sourced from Eastern European countries. They're not part of our character set in the United States. These are the things that we see that will cause this problem. Okay, we do have some tools to help you if this ever occurs. We have a tool that will help you identify where those special characters are and how to clean them up. So certainly feel free to contact us if you have this problem. We can help you diagnose it and get you on your way. There's also a table in Viewer, so once the connector finishes, it actually updates the table in the Viewer database and tells it whether it's successful or not. And this is what locks the users out of viewer if you're unsuccessful. So in 5.1 it's called OLAP database, and then 6.0 it's called AS database custom. But either way, you've got a way to, within this table, to tell whether the connected process successfully or not. Again, you really don't want to update these tables. You can use these tables for programmatic processes, or just to identify, again, another area to look for where you might have a problem. And again, this drives, again, if connector errors out, this kind of tells viewer to shut down or not, to basically to lock out users. There's also a new action log. There's actions. I don't know if you're aware of actions, but there's also a new process within Viewer that you can set up views to run on a scheduled basis. And these can run overnight or in the morning, or however you schedule them. And these log files, and they're only in version 6 of Viewer. So if you set up these actions, then you can analyze these log files to make sure that the actions process correctly. For instance, if you have an action that sends out every Friday, it sends out a weekend sales report for all your reps, and you get a bunch of calls and your reps are complaining that they didn't get the email. Well, you can come to this directory there to view the action log file and identify if there was a problem or not. Normally what happens here is that maybe you set up a new action, and the ID that you set up the action to run under doesn't have an email address assigned to it in the Active Directory, so it'll fail trying to send the email. Or maybe the ID, the action admin ID, doesn't have proper authority to put the Excel export file into the file share that you want it to export it to. So, a lot of times we'll see common, just very easy errors that we can help you identify the solution to. We've identified another issue with actions is that if you're running actions concurrently, you need to set up those actions to run under different user IDs so that you can avoid any contention between those actions. So these are the types of things you want to think about when you set up any action processing. Okay. And this is becoming more and more popular as I see as we start setting up customers with Stratum 6, Viewer 6, and they want to. This is a very neat feature, and they certainly want to take advantage of some of these features. So we're starting to see this being more popular, and this is a great way to see the log files and identify any issues. And if you're not backing up and restoring your Stratum Viewer databases or your Stratum databases, certainly you'd want to make sure that you back up the necessary databases. This is kind of telling you how to back up the analysis service, the actual cube. So in 5.1 you can set up a backup file, and in 6.0 you can actually set up a backup file as well. And you can set this up. I have a SSIS package for you 6.0 customers out there, and you can feel free, if you want to use it, let me know. But what it does is it essentially helps you automate the backup of your cube. And you might ask yourself, well, why do I want to back up my cube? Well, what you can do, especially if your cube takes a while to process, and if you have an error overnight, you can always restore yesterday's cube, and you can restore it with yesterday's backup of Viewer in the connector SQL database, and you're up and running. So, it could be a nice, convenient way to get back up and running, or a good plan B in case you experience any connector errors overnight. So, it's a great way to, even though the data might be a day old, or, basically a day stale, it's still, users can still get in and run views and analyze data. So, another thing to think about, if you're not backing up your analysis services cube, then certainly it might be something that would benefit you. Okay, I'm going to open up the lines. Actually, let me kind of show you a little around this. I've got a SQL server that I wanted to kind of look at some of these directories just to make sure we know where we can find some of this stuff. I've already got some directories set up here. As you can see, Here's my server directory. So for my server, my SQL server, I've got my server code loaded into this directory, where if I go into DT prod, obviously there's all my programs. And like I said, in DT logs, when we're using the SSIS, we set up a different folder to hold our log files. And as you can see, here's a load B1. So here's my log file for the B1 category. And as you can see, we're clearing out. There's been some clearing out that's been done. We can also see a data load right here that is occurring here, where we can see that there's your DSL lag, among other processes that are occurring. Here's what you want to see at the end of this load. Obviously, it ran successfully. We can see that indeed the NCNT finished successfully and the load was complete. Here we can see input records. There were 2 read, 1 only used, and that could be because of, well, to be honest with you, that'd be interesting to find out why it only loaded 1 record. It might be worth investigating. But this is a sample demo database, so it could be anything really. But normally you'd want to see 2 read, 2 used there. But at the end of the file, as you can always see, you always want to see a good successful end there. It'll tell you whether it's successful or not, and as you can see, you got a nice clean ending to that file. So that's your load file for your each one of your categories. You might have one in here for your master file loads as well. I don't know if I have one available. But this is also where your master file load log file would end up as well. Here's the GI log, and it might have some additional information in there. There's all my load OLAP stuff. So as you can see, there's my load OLAP processing. And the reason why it's in GI log is probably because we didn't specify where to put that log file. So it just automatically ended up here. So a lot of times you can come in here to identify if there's any problems with your load OLAP and create OMAS jobs. So that's on the server side. If we look at the connector, in terms of where to find the connector logs, then we need to figure out where the connector was loaded. Typically, it's under program files, either on C or an off drive, and under Sylvan software. And as you can see, I've got a lot of different connector builds out here. But we can see that if I go into one of them, you'll see a log file where you can very easily go in and identify the log. As you can see, you get one for each time you process it. You'll get a log file for each day. And then if you run processes within the same day, it'll just keep appending that information to the same log file. If we see this connector log, we're doing a full process. It initially gives you information about the servers involved. So that could be enlightening. As you can see, we've got a multiple, tells you how many processors you have. Very interesting what it does, how much memory you have, all that good stuff. And then at the end, obviously, you want to see, well, as you can see, it did finish the process okay, but it wasn't able to send a message to the connector admin. So there's a little problem there, but nothing major. Certainly, you can fix that. But, that's where your connector log files can be found. Pretty easy. And again, typically, any common errors there would be a key error that would occur. And then for action processing, if we take a look and see where, well, basically all your viewer instances are out here as well. Let's see if I have any. So I go under where viewer is installed, and as you can see, there's a log folder there. If I go in there, I can then go to view action. That one happens to be empty. I don't know if I have any actions that ran. Let me see if I can find it. Here we go, one that I ran in March. And this one bombed. So there you go. It failed sending the email. So I'd have to do additional research as to why that happened. But normally you would see a successful end here. It'll say action test finished successfully. Whereas this is a good idea. Here's a good example of an action that didn't run properly, and I could see that it had a problem sending out an email. So that would point me to probably the user ID that I'm using to send out the email. So I'm probably using a Windows task to execute this command line for this action, and then that user ID that I scheduled the task under probably doesn't have an email address assigned to it. So that's probably my first area that I would look to solve or resolve that problem. Okay, but that's where your action logs are, and obviously that can be very helpful in terms of analyzing your actions that get processed on a nightly or weekly basis. Okay.